So on top of connect, or instead of connect, we sometimes need to be able to connect an axis together at a certain ratio and then disconnect it again temporarily. So connect is a continuous one. For a flying shear, so a flying shear like that, we're moving along with the component on the feed mechanism to synchronize with it, and then we do whatever action it is, cut it, and then we want to retract back again. So we've got a temporary connection. So using connect in this case isn't possible. Even if you use clutch rate with connect to accelerate it up, you don't get synchronization because clutch rate is done over time. It's rate of change of ratio with time. And we want to change the ratio with position, so that we have a position lock between the master and the slave. And the command that does that is called move link. And it basically does an acceleration, synchronized part, and then a deceleration, trapezoidally. There is a move link version actually that does it with an S shape as well, so that's another alternative. It's got more parameters because it's got more to do. We've got accel and decel, so we've got our distance we're going to move on the slave, and then the link distance, that's distance corresponding to that moved on the master, an acceleration distance and a deceleration distance, and then we tell it what the master axis is. So 5 parameters there. If we look at the different segments of this, what values we need to put in are, on the distance one, it's the total distance of the slave, so all of it, the combination of the accel, constant speed and decel all together. The link distance is the same on the master axis, it's the total movement on the master axis corresponding to that. And then the acceleration distance and deceleration distance are just those portions, those segments of the motion. But notice they're pointing to the master axis movement, so the accel and decel distance are actually given the distance on the master axis. So it's not the distance here on the slave, it's the distance that it sees on the master. So in fact, on the move link, the only parameter that refers to the axis you're running on is the first one. Everything else is to do with the master axis. Okay. Now, does everyone agree with that statement there? If I do a velocity time curve, the distance moved is velocity times time and is therefore the area under the graph. Yeah? No one disagree with that? It's kind of late high school maths, I suppose, or early university maths, whatever. So, before we go to that, can anyone see a relationship between, if you imagine that is a triangle there where the acceleration is, can you see an obvious relationship between that and the corresponding area under the curve on the master? Not one-to-one, no. Because if I take that red line there, which is that acceleration, and I move it down and put it inside that rectangle, the area under the triangle is half, yeah. It's exactly half.
Oh, yeah.
So the distance moved on a move link with a trapezoidal acceleration curve is exactly half on the slave compared to the master. And that's a fixed geometrical or mathematical rule. We can't break that. So that actually tells us what parameters we need to put in. So if I look at some numbers here, we've got 600 millimeters of movement on our slave available. If I look at this step by step, I have to invent some of these numbers because I just kind of, I have to make something up. So I've decided out of that 600 millimeter movement, I'm going to have 500 millimeters synchronized, 50 at the beginning and 50 at the end. I could have chosen different numbers. I could have said 400 and then, what would that be? 100 each end, is that right? Yeah. But anyway, I've chosen that. So if we look at it bit by bit, the acceleration part, we've got 50 millimeters of movement on the slave, but by our 2-to-1 rule, we've actually got 100 millimeters of movement on the master at the same time.
Yep.
So the move link to do that is a move link with 50 on the slave, 100 on the master, and I've actually put all of it in the acceleration part. So the bit down here That's the acceleration parameter. This is the deceleration parameter. So we've got nothing in decel, everything in the accel. So that move link will actually do exactly what it shows in that little triangle at the top. And if I run that, it would accelerate up and then suddenly stop. So we don't want that. We want to add on to the end of that a constant speed part. So that's really simple because it's just 1-to-1. So we've got 500 in the distance, 500 in the link distance with nothing in accel and decel. So that's giving me my rectangle. And they will merge together. The move buffers will actually do that, and they will merge together without any jumps or breaks or anything bad going on. And obviously the decel bit is the opposite to the accel. So I've got my 2-to-1 ratio, 50 to 100, nothing in the accel and everything in the decel. So I can do my flying shear motion with 3 move links merged together, and that will actually work. But obviously we prefer to have it as one. So if I just add up the columns, so if I add up my 50, 500, 50, and it gives me 600, that's my movement on the slave, that's what I wanted. And if I add up the second column, I get 700, and then the third column 100, fourth column 100. And when I started looking at trio stuff, and I looked at the move link, I couldn't really get my head around it just to begin with. But by just adding up the 3 moves like that, it's quite simple to see what's going on. You can see that 700 is needed, but if I just wrote that as one command, you'd think, well, where's that 700 come from? But it's come from, say, this 2-to-1 rule just on the accel and decel parts. You can actually sort of obviously write it down as a rule. You can make it the link distance, if you like, is going to be the distance, that's our 500, plus the act dist added to the deck dist, all divided by 2. So that also gives you 700 with that equation. So that's kind of where it comes from.
And the acceleration and deceleration always have to be the same?
No, they can be different.
Okay.
They can be different. So the only rule is that there's this 2-to-1 ratio. So what you can't have is to say, well, I want it to decelerate over 100, but I want the slave to also be 100. So as long as it's the 2-to-1 rule, then any will do. That's probably the reason why they are different. They're different parameters, so you can have them separated if you want. So I've got a little test for you now. So there's 180 millimeters of movement now, rather than 600. So given that little picture, and I've put the move link command there, can you just, for a couple of minutes, just work out for yourselves what the move link will be to give you that? So I can give you a clue with this, in that the total distance under here I have given you already, and that's the 180 millimeters over there. Yeah. So the first parameter in the move link will be 180. I can give you that. If you hadn't worked it out already. But I just want you to decide. You decide for yourselves what the acceleration, deceleration parts will be. I have a value in my head, but you can do what you want. So my solution was that, the same as Hoy's actually. Surprisingly, he read my mind.
Okay.
So I just chose 40 millimeters or 20 millimeters, should I say, for the accel and decel, with 40 in the master axis. Okay, so I think we kind of got our heads around that. So the move link can be used like that. So in that particular case, it's waiting for an input to come on, the rising edge of an input, and just triggers it and makes it follow forwards. You can actually go backwards as well, so we can put a reversing move link in that will retract it back to the original position again. And you can see on that one, actually, I've not obeyed the synchronization rule. I've just put 60 and 60 and 180 in there. That's just to get it back quickly. We're not interested in synchronizing when we're going backwards. We just want to get back quickly. So in that particular case, it's actually going at a higher ratio.
Or we can use the ABS
Yeah,
0.
exactly. So instead of the advantage of a reverse move link is that it gets softer as the machine slows down. If you use a move ab 0, yes, it can be more efficient, but it's always going back at the maximum speed.
Okay.
But you definitely always go to 0 every time. So yeah, there are advantages both ways. The move link can have starting conditions applied to it. So rather than in that previous slide where it was waiting for the rising edge with a basic program looking for waiting until the input's on, that obviously has some delay in that you wait till the input's on, then you load the move link. Well, loading the move link takes at least a millisecond, maybe two, and then so the move link starts actually a little bit after the rising edge. It'd be much better if the move link started directly on the rising edge. So to do that, we can actually preload the move link with a starting mode. So you preload the move link in with this mode set here, and if it's a 1, it's looking for something called a registration event down there. This means that it's a special input that is looking for this rising or falling edge from a sensor. If you've got option 2, it's looking for a particular position on the master axis, and you put that position in the extra parameter on the end there. And then if you've got option 4 set, or option set to 4, the move link will repeat cyclically, automatically, so it will just continue to run a bit like a connect. So you can do something like a connect if you do a move link, say you did move link 500, 500, 0, 0, so there's no accel and decel. With option 4 set, it would be like a connect. It would just continuously have the two axes geared together. And in that case, you are using units, so it has an advantage over connect in that you're applying units to it. You don't have to worry about what the encoder counts are, because it's taken care of. And all of these motion commands like this that do link motion, they all have the same options. So when we look at flex, link and cambox, you can do the same thing. There are more options that are not covered on here. There's another option that allows you to make an S profile instead of a trapezoidal one. So if you want an S ramp start, there's another option for that. It's all in the help file. Okay, about half an hour ago I talked about rep dist and the ability of that to maybe give you a cycle time or a cycle distance, which is your process distance, if you like, rather than just 0.360. In this case we're talking about we can use the rep dist to set the cut length. And the reason we can do that is we can use one of the abilities of the move link, as shown in the previous slide, that we can set this move link to start on a defined position. So if we set the move link to start on 0 every time, okay, then we set the rep distance to the cut length. After one length, it will go back to 0, and then our move link will start. So we're kind of doing an automatic move link trigger on the repeat length of whatever we want to cut. Okay, so we're looking at plain material here. It's not got any marks on, so we're not worried about synchronizing with anything on the material. It's just we want to cut it to exactly that length. Sorts of things we've been involved in. These metal strips in the ceiling, they want those to come out of a machine. They're being extruded or whatever, or rolled out, and they just want to cut them to however many meters long. So you have a flying shear that does that. It just chomps them, and then they go into a container, and then go off to the builder.
After that, you pack
Yeah.
it.
So all you want is you want to repeatedly produce 5 meter lengths or whatever, or 1 meter length. So all you want is a length in there. So there's a move link program, which is what you've got in your notes. The bit about where it starts, or where it says it's synchronized, what we're doing here, the technique we're doing here, is waiting until the position on the axis has got to 25. So it's taking 20 millimeters to accelerate, and then we wait until it's got to 25, so we know it's accelerated and is settled in position. Yeah, and it's settled in lock. So that's one technique you can use. You can just put a position in there. Another technique would be to split the move links into the 3, as we did before, and then you can start your action on the second move link running. Yeah. So you can do a move link for the acceleration, a move link for the constant speed, and then arrange it so it starts whatever cutting action you have once the second move link starts. So that's option 2. Another one is to use something called a P-switch, which is a position switch that comes on automatically at a position. So you can set a P-switch up so it fires an output at a certain position. So there's a few different options. Okay, on this particular example, we're not actually saying that we're output to cutter output is making the cutter lower, and then when it's off it raises. We're saying we're firing sending a signal to a PLC or something, which is doing the cut action itself. So we're just giving it a trigger signal, which is why the output goes off only when it gets to wait idle, which means it's obviously decelerated. So the output is still on even during the deceleration part. But again, you could change that. You know, the OP on, there's another command that turns an output on for a time, so you could use the timer command. So instead of the OP on, you could say timer. I think it's the output number. So the output number there is called cut, and say 200 milliseconds, for example. So you could pulse an output for 200 milliseconds with a timer command. So again, there are different options on how to do that. Cut length is declared up here. So that's input 5 or output 5. Sorry, no, that's VR5. I beg your pardon. So VR5 is where the cut length is held. So you need to do that in your Motion Perfect. You need to put a value in there in order to run this, and that value must be the minimum cut length you can do is the addition of that value and that value. So those two added together is 400. So you cannot do a cut less than 400 because you've got to give it time to do those two move links. And actually, probably even at 400, it would miss every other one. So you need to really have a cut length that is maybe 420 minimum in order to make it work. So that goes in VR5. And I'm not sure in the sheets whether I was looking for that needs to be declared somewhere, output cut. So you need to tell it what output you're going to turn on. It might be in your notes already, but just in case it isn't. So there you go, that should be enough for you to have a go with that particular little project.
This is an example of a trio flying cutter or flying shear application, simplified, using two axes. One axis representing a conveyor and another axis representing the cutter. And typically the cutter is on a reciprocating slide motion sort of mechanical arrangement where it's going to sync to the conveyor motion-wise and then do some cut action or glue or something and then retract back to the home position. So we've set this up, made some quick assumptions by setting the axis 0 as my conveyor, and we've set that into forward motion just to simulate the conveyor moving. The cutter is going to be on axis 1. We've also reset the positions to 0. Normally this will be a homing process or something on the slide. So some key things here to set up. We have a parameter called repdist, and repdist is the repeat distance of an axis. In this case we've set it up to be the conveyor's repeat distance. And then we've set a variable called cut length. So what cut length actually does do is sets the cut length based on the position rollover of the conveyor. And that value is set here. So this value represents my cut length. And as we move along here, we'll see how that happens. So then we have the rep option, which is simply saying I want my position on that axis to go from 0 to repeat distance, or 0 to 8, rather than going to negative values. Then we use a command called moveLink, which allows me to trigger a motion geared to another axis. And we have a lot of options to trigger that command, and so we're going to use option 2, which allows it to trigger on the master axis position, or the encoder in this case. So we're going to move on then down, so the entire motion is done in this loop here, where we set the base axis. So that's my cutter slide. And then we've broken up the moveLink into 3 portions to make it easier to follow and easier to set up. So the first moveLink sets up the trigger action. So the option is put here, and then the trigger position, in this case we've set that up here somewhere as 0. So basically when the counter rolls over, I want to trigger my move. So when we set this up, this is the distance for the acceleration portion of my move. This is the distance of my constant velocity part of my move, and then this is the distance of the decel portion of the move. And by putting them together back to back in a program, they will put the controller will buffer the moves and seam it together as one move. These commands right here are just to trigger the scope so we can see what's going on, but normally wouldn't be used. This loaded, however, does make a difference, and what that does is that waits till these 2 moveLinks get loaded before I fire my timer output, which fires my simulated cutter, which is on output 8. After that timer fires, then the move will finish out, and then the decel will happen, and then we go to a non-linked move back to home, or a move absolute back to home. So the values in the moveLink are determined by the distances I want to use. In this case, 1 inch, we can call it, on the master axis is going to be represented by 1/2 of an inch on the slave during the accel portion. Since the slave can only cover half the distance the slave or the master is moving in that same time. This is the accel distance of the master axis. This is the decel distance. In this case there is none because this is just acceleration here. Then the second portion, it's equal because I'm moving 1 to 1. No acceleration, no deceleration. And then finally, again, 1/2 to 1 of the master. No accel, and of that 1 unit, all of it is deceleration. And the master axis is the conveyor on all the moveLinks. So if we have a look at our scope here, do a one-shot, and we can see what's happening here. So we'll bring on some cursors, and this is the accel portion of the moveLink, this is the sync portion, this is the decel portion, and this is my move absolute back to 0. And then my repeat happens at this point. So this is the output firing at the top of my accel ramp, which is where I want it to fire. So if we want to see what happens when we change the rep distance, which is effectively changing the cut distance, we'll come over here and change that to 10. So we changed the cut length now by changing the repeat distance. So let's have a plot look at that now. And we will decrease the time here, or increase the time so we can get a between cuts time. So by using the cursors, we can measure the rising edges of the output. So let's do that real quick. So that is now the difference between these 2 times up here, which is 2.6 minus 0.9. So about 2.7 seconds for that. So if I change it to back to 8, rerun it, which is now a shorter cut, that time should be shorter, as we would expect for a shorter cut. And that now is 1.9 to 0.6, so roughly 1.3 seconds. So you can quickly see how the time between cuts changes based on the cut length, which it obviously should. So that's a very simple application of cut using a position trigger on the conveyor. Okay, so now we've made a modification to the program to trigger the move instead of a position on the conveyor on a registration event on the conveyor axis. So on a physical input. So when the input goes true, that triggers a registration and it triggers the move link, which has now a new trigger option. So let's take a look at that. So all we had to do this is add a couple of commands here. So we switch over to the conveyor axis. We then use the simple regist20 function, which sets up a series of basic parameters. So the first 0 being channel A, so just a single channel capture. The second 0 being the first input, or the default input, which since it's axis 0 will be input 0. The third 0 is the edge. In this case, that's a rising edge. And then the fourth 0 is for no windowing. So it's a basic registration function. And we then switched from a 2 to a 1. And if we want to look and see why we did that, we can go look at the move link help system, and we can see very quickly that the link option here is bit 0 or value number 1. The link commences exactly on a registration event, or a mark flag gets set, which occurs on the link axis, which is the master axis. So by setting that up, it is now armed, and the move link is in the move buffer here. So if I come over to my scope, flip my physical switch on my unit here, and it now triggers the same move event that we've had before. But in this case now, it's not waiting for the position. So this would be a setup you would use for triggering a move on for a label feed or something like that. Some event that needs to happen physically. So that's two examples of triggering the move link command, which is a geared move to a master axis.